In this activity, we're going to use Snell's law of refraction and also the law of reflection to draw several beams that are created when an incident light beam approaches a new medium from air. Now, we don't know what the index of refraction of this block material is, but we do know that our light beam is approaching from air. And when a light beam travels through air, we assume that the n is approximately 1. Light speed in air is just about the same as it would be in a vacuum. Now, one thing that we're given here is that the angle of incidence is 45 degrees. That is the angle of incidence. Now you have to measure the angle of incidence against a normal to the block surface. The normal, of course, makes a 90-degree angle with the surface of our new medium. All right, now when our light beam strikes a medium surface, it can be reflected. And we can see that above in this example here, where we can see that the incident laser beam comes in to this material, which is lucite. The angle that it comes in with is the angle of incidence. And so part of the laser is going to be reflected, and that's theta r, the angle of reflection. Now we find that for reflection, the angle of incidence equals the angle of reflection. And so that's what we want to draw in our example here. So for that, we want to use a protractor. Okay, we'll line it up as best we can. And the angle of incidence was 45 degrees. So our angle of reflection needs to be 45 degrees as well. Okay, so this will be theta r. Not all the light gets reflected though. Some of it will travel into the block itself, as was seen in this example here. But the light beam will bend if the index of refraction is different inside the block than it is outside. So, in this problem, our angle of refraction is found to be 32 degrees. So we just want to sketch that. In order to sketch the angle of refraction, what we want to do is we just want to extend the normal so that it goes into the block. And then we want to measure the angle that the normal makes with the refracted bent beam. That angle is often called theta 2. Alright, so let's extend the normal. Okay, now we want to find 32 degrees. We'll have to subtract to do that. And it looks like 32 would be just about there. Okay, so this angle is theta 2, which is 32 degrees. We also want to determine what that index of refraction for the material is. To do that, we're going to use a thing called Snell's law. Snell's law gives us a relationship between the angle of incidence and angle of refraction, and also the indices of refraction for the materials involved. So according to Snell's law, n1 times the sine of theta 1 will equal n2 times the sine of theta 2. Alright, so theta 1 is just the same as theta I here, and n1 is 1. So the left side of this is all for the beam traveling in air, and the right side is going to be for it traveling in this block. N2 is what we're trying to find, and we know that the angle of refraction is 32 degrees. Alright, so let's label these n's as n1 and n2. And using algebra, we can determine that n2 is approximately 1.33. There are still more rays to draw, though. Upon reaching this boundary between the material and air, we can again have both reflection and refraction. So to sketch the reflection, we'll want to draw a normal to the boundary. We'll want to figure out what angle the beam is coming in at. Now, by alternate interior angles here, this would be 32 degrees. And so our beam is going to reflect internally at 32 degrees as well. Some of the light will reflect, but some of it will pass through to the other side. So now we could use Snell's law again to figure out what angle the light beam emerges at. So let's do a Snell's law for the emerging light beam. It'll be 1.33 sine of 32 equals 1 sine of theta. And this is the theta of exit. If we solve this equation, we find that theta actually matches the angle of incidence that we had originally. Alright, so let's find 45 degrees. And this angle here will be 45 degrees. Alright, we'll draw just one more beam here, and that will be the beam that comes out of the material at the top. That way what we've constructed will be similar to the picture shown. Alright, so there's 32 degrees here. By alternate interior angles, this will also be 32. And the beam will emerge at a 45-degree angle. Alright, now our drawing is complete. We'd also like to guess at what this material could be. We can use the index of refraction to make that guess. So I would go to reference tables. Here's a table of some common indices of refraction. And we can see that ice and water are certainly in the range of possibilities. So this material could perhaps be a block of ice.